harmful algal blooms, science and solutions. I'm your host, Trent, from the Trent Conservation Coalition. I also have on the call Natasha, Kelsey, and Marika from Quinte, Cataraqui, and Rideau Valley Conservation, respectively. They'll be helping to moderate the chat and provide any technical support if needed. Just some quick housekeeping items. Just a reminder to everyone, please mute your microphones and turn off your videos if you can to prevent potential distractions or connectivity issues. This webinar will also be recorded and available to watch on YouTube afterwards. So if you have any friends, families, or colleagues who are unable to make it today, if you search Drinking Water Wise webinars on YouTube, you should find all of our previous videos there, and this will be up there shortly. If you'd like to participate, you can do so through the chat function on Microsoft Teams. Just look for the little button there. And if you're experiencing any technical issues, please contact Natasha Matthew at the email listed on your screen. Oh, well, now that we have that out of the way, let's begin with today's webinar. Quick agenda here. First, I will go over a small presentation about the best practices for source water protection. Then we will welcome our guest speaker, Dr. Amanjot Singh, for his presentation on harmful algal blooms, specifically cyanobacteria. And then we'll finish off with some Q&A. I will note at this time that while there were several pre-submitted questions, and we do appreciate them, our guest has attempted to include coverage of most of those questions in his presentation itself. If there were any that you feel weren't covered, feel free to ask them in the chat, and we will try to address them following the presentation. So first, I'd like to briefly go over the state of drinking water source protection in Ontario. So Ontario has one of the most comprehensive municipal source protection programs in the world. It's most recognized by our lovely drinking water protection zone sign shown here. So the whole program largely came as a result of the Walkerton crisis in 2000, where E. coli entered the town's municipal drinking water system, resulting in thousands of people falling ill and sadly 7 deaths. So as a result, a multi-barrier approach to protect drinking water from source to tap was developed. So the Clean Water Act was established in 2006. This is the formal legislation backing the program and has several components to ensure that municipal drinking water is safe for consumption. This includes the Ministry of the Environment, Conservation Parks, and Conservation Authorities working together to develop and implement source protection plans and assessment reports. So these plans contain policies to address specific drinking water threats and activities. The other sort of leg of this is risk management measures. So these are negotiated with people engaging in activities in those vulnerable areas that may affect municipal drinking water sources. So this leads us to the main reason why this webinar series was initiated, which is the best practices for source water protection. So because not all systems are protected by this multi-barrier approach in Ontario, roughly 500,000 households in Ontario have to rely on protecting their own sources of drinking water. Fortunately, there's now something called the best practices for source water protection. The best practices are a voluntary guidance document developed by the Ministry of the Environment, Conservation and Parks with a goal to aid in protecting drinking water sources that are not protected by the Clean Water Act and/or a source protection plan. Following all of this document is particularly applicable to private drinking water systems such as wells and lake intakes for rural residents. This document walks the reader through how to identify vulnerability in the drinking water systems, how to assess their local setting, identifying potential risks, and how to manage those risks to better protect your drinking water. It also includes useful information for private residents and even smaller municipalities and other agencies and associations. So why are the best practices important? As I alluded to a little bit in the previous slide, the best practices were created because there's this clear gap between drinking water protection for those on municipal water and those that rely on their own private drinking water system. So as you can see in our diagram here, private system owners have the responsibility to ensure that the drinking water is safe by doing their own testing and treatment without being a trained professional. Whereas on the other hand, municipally treated water has trained professionals along the way that test and treat your water and to ensure it's safely distributed to your home. So you have to basically be your own private drinking water expert when you don't have all of these other professionals to rely on along the way. So why are the best practices important to implement on your property? Here's a few reasons why you might want to consider implementing these simple practices. Ultimately, the main reason why the whole source protection program came into place is to protect human health and the environment, but it can also help extend your drinking water system life and avoid potential high costs associated with cleaning up any contaminated drinking water sources, having to find a new source of drinking water, such as siting, digging, and installing a new wells can be very expensive, as is installing water treatment systems to treat contaminants. Um, it can also help you make informed land use planning decisions. This can be things such as considering the location of a shed you may store chemicals, where you park your vehicles or boats, as well as the location of your septic system. And it can also help increase public awareness and accountability for your drinking water stewardship, since most rural landowners often share the same source of drinking water, be it your lake or you're probably taking water from the same aquifer. Over the next few slides, I'll just highlight a few measures the private system owners can undertake to better protect their drinking water system and supply. Probably the biggest one is just testing your drinking water regularly. They recommend seasonally, but especially spring and fall. You can implement a protection zone. So this is basically straight out of what we've learned from the municipal system, typically a 100-meter radius around, if you have a well, around your well is recommended. Visually inspecting your wells and septic system, pumping out your septic system every 3 to 5 years. For more information on those, I highly recommend checking out our Wells 101 and Septic 101 webinars we held previously. A couple more here. Being aware of potential signs of drought, particularly during late summer. So you might need to conserve your water more. Using hazardous waste drop-off locations around the province, making sure fuel tanks are in good condition and regularly inspected, and perhaps most applicable to today's guest presentation, keeping a shoreline buffer to reduce runoff on waterfront properties. I'm sure we'll get to more of why that is important shortly. But this concludes our short discussion about the best practices. Be sure to follow the link in the chat to that to find more information. But now I'll turn it over to our guest speaker. Dr. Amanjot Singh is a PhD, PEng, works at Credit Valley Conservation as a senior engineer in water quality. He joined Credit Valley Conservation in 2008, and before that he worked and studied in India, Germany, and the United States in different capacities. His primary passion is watershed water quality and quantity modeling. However, for the last 4 years, he's engaged in cyanobacteria blooms forecasting and testing emerging technologies like microbial source tracking, eDNA sequencing, and drones for water quality monitoring, which we'll all hear a bit more about. Dr. Singh is also an adjunct professor at the University of Guelph. So without further ado, I will stop sharing. And Dr. Singh, if you'd like to take over.
Well, thank you so much, Trent, for the nice introduction. So here we go. Okay. So, like Trent mentioned, that I am with Credit Valley Conservation, and I've been working on different water quality issues. Actually, my career started here, not here, but before joining CVC at the Nebraska Conservation Authority on Tier 1 source water protection. So that's very well linked to, I think, the topic or the organization or the people who will be attending this webinar. Um, by no means I'm an expert in cyanobacteria, and particularly I'll be talking about cyanobacteria, harmful algal blooms, rather than some others which also happen. But this is kind of my journey for last at least 4 or 5 years now, having been engaged under different capacities, first as water quality lead from Clyde Valley Conservation on different municipal water quality issues and technical teams. And now, after that, we started collaborating and did some projects which I'll be talking about. But like I said, that this is more of my journey, learning about cyanobacteria and related associated harmful effects. So if you folks have different experiences, feel free at the end to chat about that. I'll look forward to learn from your experiences too. So, like I generically like some background introduction and the journey, and there was a there's a study which is still undergoing, which is Fairy Lake study. I'll talk about that and upcoming projects, and a couple of slides on like what can we do actually at our end to make our water bodies resilient, and a couple of resources which may be helpful for you and at different capacities. So, the first thing, being an engineer, I have always thought that, okay, you know what, engineers are, high level, they do designs and all the stuff. But as I got more indulged in biological aspects, especially because I'm working more on like aquatic water quality stuff. Hats off, man, to all the biologists who do all this hard work in identifying species and toxins and all the stuff. I'm totally blown out and really appreciate all the effort which is going on in this direction. So, like I said, not being a biologist, I'm learning a lot every day, talking to different people, different experts in different spheres. So that's what I'm going to share. Just to recap, for those who do not know about Credit Valley Conservation, Credit Valley Conservation, the head office is in Mississauga. The river starts from Orangeville and drains to Lake Ontario at Port Credit. We have a number of key municipalities in our watershed, like Mississauga downstream, and then Brampton, Caledon, Halton Hills, Orangeville, and regional municipalities of Peel, Halton Region, and also a part of Wellington County. Um, so I mentioned like means my journey more or less started with Fairy Lake, and it's irony when in 2008 I started working at CVC. My first project was Black Creek subwatershed study, and Fairy Lake is part of that. And we were collecting, samples, analyzing samples and stuff. But at that time, yes, Fairy Lake was identified uh, as a as a place which was very popular amongst local residents, and its water quality issue here and there was raising some questions. But my cyanobacteria project journey for on Lake Fairy Lake started kind of around 1999-ish, and I'll show you that what we did and how we are doing. So again, like any reasonable sized freshwater inland lake, Fairy Lake is very popular for recreational activities, whether it's ice fishing, normal fishing, boating, or any events that may be happening. So it's popular. And once COVID started, it became even more popular. amongst neighboring municipalities and was being used. And when you have a popular lake, and then you don't want to see these type of signs coming up. It becomes problem for the managers, the beach closures. It used to be more or less for E. coli purposes after the rain event, but for last about now 7 8 years, it is because of cyanobacteria. And the problem with cyanobacteria, resurgences is that once a lake has cyanobacteria bloom, then municipalities have to put a warning sign that the access is not safe because of so much dynamic things which are related to cyanobacteria that you can't say that yeah, it's present or its toxins are present today, may not be present tomorrow, or they may be even worse tomorrow or day after, right? So as a precautionary thing, those beaches, once they experience this type of a bloom, they are always posted as not uh, recommended not to be accessed for recreational purposes. And in general, like means when we are talking about cyanobacteria and other type of algae, the primary cause has always been identified as nutrient enrichment. More nutrient you have, more chances are there will be aquatic vegetation, including all type of algae and cyanobacteria there. Warming is playing another role. We see that the ice-free periods in these lakes has reduced, and that's also something which is making the reoccurrences more often than they used to be. So, given that, uh, and also sometimes water stagnation is happening because of the different conditions. There's not enough circulation. Or another thing which we have been experiencing now is the lake clarity. Sometimes the lake is clear and the light can penetrate through the full column, and if light is there, nutrients are there, the warming is there. It's an optimum recipe for any kind of aquatic vegetation to grow, not only cyanobacteria, but cyanobacteria loves that. So that's the reason, these blooms are becoming more prevalent. But another thing which was interesting was like, okay, if these are the things which are important, then the beach closures sometime were happening all over. And if you see that they could happen in October, they could happen in May, they could happen in August, they could happen in September. So why is there so much spread of the time period when cyanobacteria can grow? So that was the question which was uh, back and forth coming to my mind, and I was saying, you know what, the only thing focusing on the nutrients and some apparent stuff is not enough. It's combination of all these. How dynamics plays in, that's going to tell us a better story or give us a better understanding on like under what conditions cyanobacteria blooms can happen and when can they become harmful. So that's what triggered that I asked my partners, the Halton region, town of Halton Hills, and the DHI is a private company who does lots of software development for different water quality and quantity products. So I thought, okay, you know what, let's partner and contribute a little bit. And through my University of Guelph contract, like, let's see if we can get a small pilot project just to understand how the dynamics of cyanobacteria work. And uh, we were really fortunate that funding came through, and we started this project in 2021-ish or more, in 2022, when we started to collect the data, and I'll talk about that. But while I was doing that, I thought, okay, you know what? Let's take one step back, or let me take one step back and see, why cyanobacteria are actually existing, right? I feel myself that everything which is existing on this earth or universe has some purpose. So it's not that cyanobacteria is out of the blue, something which is really bad, 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 and labeled bad. There should be something where we are missing to understand that how things was. And it was again mind blowing to see that cyanobacteria have existed 2 to 3 billion years back when nothing was there. And they were the key element in this on the earth to create oxygen. And that's where the role started. The oxygen which we are enjoying today was actually started by cyanobacteria billions of years back. And as they evolved and as the other ecological features evolved, they also started to fix nitrogen as a nutrient from atmosphere and provide it to other aquatic flora and fauna. So it became started to become the suppliers of nutrient. So that's again a very important piece which of the puzzle which cyanobacteria have played since long time. And then once they die, there is release of phosphorus and other nutrients, which is again available to the food chain, which is an important part. Now, why we are talking about cyanobacteria, but why it's called blue-green algae, right? So it should not be called blue-green algae. So I looked into more into this thing, and the reason cyanobacteria initially were called blue-green algae because they have chlorophyll, the green color pigment, which is important for photosynthesis. So these are bacteria, but the main thing is the chlorophyll, which gives them green color. And it is phycobilin, which is the blue pigment in blue-green algae or in the cyanobacteria, and that's the reason they are called blue-green algae. Then that's how they are differentiated from the green algae. The roles are very similar to algae, and that's why we are still stuck calling them blue-green algae, knowing that they are actually not algae, they are bacteria. And this is how the structure looks of green algae and blue-green algae if you look under a microscope. So their presence, that's another thing. Like all the water bodies have cyanobacteria in them, whether they are saltwater oceans or seas, whether they are rivers, whether they are kettle lakes, or whether they are shallow urban freshwater lake. One form or the other, they are always there. But we may not notice it because they are not blooming, and there are not enough which are visible through the naked eye. But they are important part of our ecosystem, and we don't want to eliminate them, but we also do not want them to bloom too much so that they are impacting other ecological processes. Another thing which blew my mind was like how smart cyanobacteria are. Cyanobacteria, you can see them, they have a bloom at the upper part in the open water body. You can also see them bloom in whole photic zone where the light is available through the column. They can even go to metaluminous zone where again the light may be limited, but other conditions are optimum. They can have a bloom there. They can move around in the columns, or they can cover the entire lake column depending upon what the conditions are. And which really was a very new thing to me, that you can find cyanobacteria blooms even under ice, and they have been reported here in Ontario, they have been reported in Alberta and many other places. So that means, yeah, we always say that warming and the temperature is a very important factor, not during ice periods, right? So there are other factors which probably are triggering cyanobacteria to happen. And what is creating that? How they're smart? They have a buoyancy mechanism, right? So that's why I'm saying that cyanobacteria versus submarines. So what is the commonality in that? So they can, depending upon where the ideal conditions are, they can make themselves float in the column of water, or they can go across wherever the ideal conditions are. And interestingly, they don't implode. Right? Once we have created cyanobacteria, they may explode or implode, but cyanobacteria are so smart that they know where to find optimum conditions and then grow and provide services. And if they are blooming too much, then they become an issue. So again, coming back to like cyanobacteria, we hear blooms we hear, and also we hear about cyanohabs, which is cyanobacteria, harmful algal bloom. So how they differ is cyanobacteria, like I said, they are always in the system, and because they are not visible to us and during non-bloom periods, so we just say, okay, cyanobacteria, they are there, happy, we are happy, they are not visible. But once the conditions are favorable and they are getting enough nutrients and they are getting enough other parameters which are important from them for them to grow, then the mats are created and scums are created. That's when the problem starts. What kind of time of problem? They also compete for the nutrients, but they also, once there are too many, they could cause anoxic conditions, and that could lead to death of fish or other aquatic life and create conditions which are not desirable. When are they called the harmful algal blooms? That is when certain type of cyanobacteria, they release toxic material or toxins, and that is where when if the toxins are there, that's when they are called harmful algal bloom. And I'll talk a little bit more about that. Just to give you information, there are more than 2,000 species of cyanobacteria, and all of those species are not harmful. The only ones which are harmful are the ones which create toxins. So these are the more common ones which we experience in our part in Ontario and overall in Canada or North America. Microcystis is the key one where we want to focus on. And what they do, most of these, I've provided a list here. They can impact our liver, they can impact our respiratory system, they can impact our kidney. So that's when either they are in the recreational water and we are swimming in that recreational water, and by accident we swallow that water, then we can have nausea or other type of symptoms, which can really, depending upon like how much toxicity level is, uh, uh, that could be very detrimental for our health. So that's, and they are in different shapes and forms available when you see under a microscope. And But this is the particular time when they are called toxic, and that's what our health department test the water for, to see that what type of toxin is there and what is their level, whether it is recommended for recreational purposes or not, and then what should be the next step. But like I said, that since cyanobacteria are very smart, they can be concentrated 1 hour at one location, at totally different location and totally different depth at other time. So sometime even if we take the sample, that may not be representative of true toxin levels, and that's where to be safe on the side, once it is identified that it's a cyanobacteria and it's a cyanobacteria which can release cyanotoxins, then post the beach as not recommended for use for recreational purposes. So, like I said, why this happens? Again, a good example is we are what we are fed, right? So, if there is very good amount, or you can say too much amount of phosphorus there, there's light, there's clarity, temperature is there, and competition with other aquatic species is not much. That is when cyanobacteria blooms will happen, and once they take over, they will dominate, and other species may be suppressed. So again, that's where you probably all have heard about it, that we need to cut down on nutrients coming to our lakes, so that at least the food is not there, right? So that helps in making our lakes resilient. Um, so concern-wise, like I mentioned, the main concern is public health, whether it's for the recreational purposes or it's for drinking water supplies. One needs to be very cautious about that, and that's where the health departments come into picture. Ecological impacts, we do not want, of course, our pets to swim in the water. Number of uh, dog deaths have been reported when they have used lakes with lots of blooms in cyanobacteria bloom, the harmful cyanobacteria bloom, at different places all over the world, I would say. And even livestock, if they are fed toxin-rich water, they have also shown signs of illnesses. And of course, social economic consequences are always there. If you have a cottage by the lake which is experiencing these type of cyanobacteria blooms, I don't think you will be happy, right? And you would like to find out the reason that why it's happening and how this can be resolved, right? So these are the main concerns which are always on back of one's mind. As far as cyanobacteria life cycle is concerned, cyanobacteria can last for just hours and days, or they can go up to months at different stage. So again, this is a generic kind of a diagram starting from, say, spring, summer, autumn, winter. But basically, thing is that they have a vegetative stage when they will produce, and then they will split and expand, and then they, like I said, that they are very smart, right? So when they feel stressed, they develop some situations which is called akinetes, that they are not dormant yet but the cusp of dormancy. And then if the conditions are not favorable at all, then they will go to dormancy, and if they die, it's a sedimentation. And again, if they are dormant, then the next season they will grow and reproduce, and the same cycle would happen again and again. But they do survive, throughout the 4 seasons in the lakes. Back to Fairy Lake study. So the main objectives were like what triggers cyanobacteria. That's what I wanted to understand, or the whole team wanted to understand, and what are the triggering parameters for that, and what can we recommend for the lake managers as best management practices so that we can make our lakes resilient. So we started. I'll just focus on a couple of uh, uh, things here. This was the first thing where we wanted to see. Okay, you know what? Phosphorus we know is an important parameter which we need to consider, and E. coli is another parameter which is important. So we took the samples. We took samples for 2 years, and they were mixed of like dry conditions and wet conditions. Dry means there was no precipitation for, say, about more than 48 hours, and wet conditions, there was some precipitation, say more than 10 millimeters in last 24 hours or so. We'll go and take the samples. And it was interesting to see in the Fairy Lake that there were some locations where, if the E. coli levels were high, the phosphorus levels were high too, right? And that's a good indication that, ultimately, if we want to control phosphorus or anything, we need to know what the sources are, right? The sources could be human sources, the sources could be agriculture, it could be urban runoff, it could be, geese and gulls just walking around the beach. And if we know that what the sources of these parameters are, then it's easy to find a best management practice which will be more suitable. Otherwise, it is all hit and trial. And that was the reason I thought, okay, you know what, I've been studying water quality for a long time, but I have always felt myself handicapped in identifying the sources, right? So I don't want it to be hit and trial. Can I do something better? And that's when, I was talking to one of my dear colleagues who retired from Environment and Climate Change Canada, Tom Edge, and his work on microbial source tracking, and some other colleagues who are working on environmental DNA. So I thought, okay, you know what? Let's do some testing here and see if we get some kind of a new story out of this. So microbial source tracking, as the name is reflecting, it will tell where the microbes are coming from, right? And so that means they have a strong association with the E. coli. And if they have strong E. coli association, like I mentioned in my previous slide, there's a strong possibility they also have a strong relationship with phosphorus. So we did some sampling and we took the analysis, and that's what we found. Like means in at these different locations, we just used like because this was just a proof of concept. We could find that okay, I mean there were certain locations where the human marker was evident, right? So whether from wherever it's coming, whether it's from the cross connection, the septic leaks, or urban runoff, or whatever. But there were clear indications at certain other locations that the goal marker was highlighted and being a source. So if we go in this direction, that's where I call that we are advancing science in this direction, that we are not depending only upon traditional water quality analysis, but we are using these biological methods to give some answers to us, which are very important if we really want to manage our lakes better. So this was an eye opener and a very good study, which we are encouraging to proceed into the next phase. We also do lots of, the temperature being a key parameter, how the temperature increases, and especially when does the lake get stratified, when does it mix? When it mix, that means the nutrients will mix automatically. It's important. So we are monitoring it continuous, say starting from May until November to have a feeling, and you can see the lake is stratified here, and then you see it's mixed here. And this was one time where cyanobacteria bloom was observed. And this is something which I did just last month. We have a water quality probe, the sensor, which is now equipped with phycocyanin, which reads the blue pigment of cyanobacteria, and it has chlorophyll A, which reads the green pigment of cyanobacteria, and it also does turbidity, pH, conductivity, temperature stuff. And we wanted to see that, and this was actual bloom, which happened last month in Fairy Lake, and we took the sound out and saw what was going on there. So this is the location where the lake is deepest, about 7 meters, and we plunged this hydrolab, which was recording continuously every 10 seconds while it was dropping down. And you see at this particular depth, you don't see any phycocyanin. So probably phycocyanin had already, or cyanobacteria had already disappeared here at this location. But as you go between 4 and 5 meters, you see the numbers plumbing up. So that's where it is suggesting that where it is located now, again, providing us with more understanding on that. And the same time, when we went to the other location, we saw that, less than 2 meters, the numbers were high. There were no signs in between, but again, at the bottom, the numbers were high. So chlorophyll, somewhere it was increasing, somewhere it was not increasing. So the phycocyanin sensor is more appropriate for cyanobacteria analysis compared to chlorophyll A. Chlorophyll A has been used traditionally, but it's also impacted by other aquatic species. We also, put some trail cameras just to capture, like, means what type of, what time the geese are coming, and what other, wild life is present there. Just to, again, develop some understanding. And we did capture one time when there was a raccoon active in there. So again, giving us an understanding of how things are. But the most thing here interesting was when one of my staff member who was analyzing these photographs came running to me. He said, "I found the source of pollution." I said, "Okay, what did you find?" I knew that he is up to something against me, and he showed me this picture when I was at the site, just inspecting the site. Believe me, I was just inspecting the site. So, but these are the interesting things which happen when you are doing some studies like that. We are also doing some numerical modeling. I can't do any study without modeling. That's my passion. And we did catchment and lake modeling. And again, these are the common sources from atmospheric deposition to groundwater to urban runoff and all the stuff. And then this is about the catchment contribution coming. But then you come to the lake, and there are lake dynamics, the hydrodynamics, and interaction between the lake flora and fauna, which we wanted to understand. And we used these are the Danish models. They are called Mike Shi and Mike 3 models, which we developed for catchment and for the lake, and to understand and some very interesting results to piggyback on for our next round of the study. And this is an integrated model which has the surface routines, and it has the unsaturated zone routines, and it has the saturated zone routines. Just to overwhelm you folks, we the model which we have created has 13 groundwater layers, and thanks to source water protection folks, because they had already developed a groundwater model, we just took that the information for each layer, and we put it in the model. But again, very comprehensive model. And this is the lake model, and here you see that these lake models tell us the temperature at what time the plume is flowing, and what type of impact it may have on different things. And this is something where I was talking about the mixing of the lake, which is again very important. In August, you see at the surface that the temperatures are high, but at the bottom the temperatures are low. It just changes in September when the temperatures at the surface are high, and surface are low, and at the bottom they are high. So what type of impact they may have if the blooms are happening in September and October? This is somewhere we'll need to have our eyes on that, how temperatures are changing in different months and when the mixing is happening. Again, we wanted ultimately to have cyanobacteria simulated. So these models, the lake model, have a Ecolab module, which we are still trying to work on. Again, very interesting results coming out of that. And here you see how the orthophosphate was changing in 2 years. So it was ran from 2022 to 2023, and these were the places when cyanobacteria blooms actually happened. So we are trying to understand further that or what parameters are impacting those. And like I said, that means ultimately me sitting at a conservation authority, yes, science is important, because science is, if a management practice is driven by the science, then it has the value. And that's where I wanted to see. So we started to compile information on, I'm calling it as a management decision support system, that what type of management practices we can implement so that we can make our lakes resilient. And it could be just a treatment, it could be preventive measures. Again, it has a number of other components coming. We are building these together for non-point sources, for point sources, for agricultural, for other sources. And now what we realized, or we understood from this pilot project, was that the conditions are so varied that cyanobacteria can happen under different circumstances. And we have seen this to happen all over Canada. Even northern lakes have it. So it was like, okay, those who are interested in cyanobacteria research and work, from lake managers and scientists, let's get together and make a bigger project and study more lakes with consistent protocols of collecting data, generating more data, using new technologies, and see if we can understand it even better and create a larger data set than which then we can use for machine learning, for example, or any kind of artificial intelligence things, and see where it takes us. So happy news here is that there are now 11 partners we have come together to work on this project, and we are almost at the final stage of submitting an ANSWER application to study lakes. And the lakes start from Newfoundland and Labrador all the way to to Alberta. And some, lake managers have been collecting data for years and years. Some are very new, and some are like means which who have just experienced cyanobacteria blooms last year or year before that very recently. So we want to understand that what conditions may be, happening. Again, the main objectives are to monitor water quality and quantity to the best it could be, then bring all the data and run the models and again extract data from those models. And this is another which is a key thing which will be a part of a forecasting tool is the satellite information. So satellite data is now more and more available, and from its spectral bands, we can forecast that okay means how the conditions of a lake are changing, and when can we expect the cyanobacteria bloom to happen. So this again is an important data set which will be used for machine learning tools to crunch numbers and throw us light on that. And of course, the ultimate aim is to create a AI-powered decision support system, which will take all the data and suggest us that, okay, what are the triggering parameters of that particular lake. And believe me, every lake is, we can't cookie cut, every lake has some different conditions which encourage cyanobacteria to bloom. So this type of tools, which are advancing very fast, I need to bring them to this project and see where we go. And this is something which I did just start of this month. So we procured a drone, and thanks a lot to Regional Peel for funding this drone project, where we are trying to see that how the drones can be used for both, the spectrum analysis and also for collecting, water quality samples, and also the water quality probe which I had shown you earlier, that we can launch that at different locations and see how the numbers. And I'll share this quick video which one of my smart staff member created for me. So this is a drone, and at the bottom you see the sound. The sound is hanging here with the drone, and this is Lake Ontario, and we are going far. We went up to about 7 meters there, plunged it, and this is something which is very neat, which you see here, because this particular drone has a thermal camera, and as well as it has a spectrum, the optical camera. So you can see side by side that what is the difference between temperature and what how does it look otherwise. And we'll be switching this with a multispectrum camera so that we can identify whether it's a blue pigment or green pigment or combination of both, that how we can use this information moving forward. But again, phenomenal information. I'm so happy to have this new toy in our team, and this is how the data is coming. You can see from here like how the numbers were there for phycocyanin and other parts. Anyways, so that is something which is very new, which we are experimenting and hoping that this will be there. So you see here with the depth, chlorophyll A, and phycocyanin. Of course, lake did not have any cyanobacteria, but this is a kind of a proof of concept where the technology and the science should go as we move forward. Um, so next is the timelines for this project. Hopefully, if it gets funded, fingers crossed, we'll start it next year, and we'll be taking consistent samples for 5 years. And at the end of the year, we'll have a kind of a decision support system that I mentioned. And I have big plans after that, and that is my retirement. So this will be going to be, anticipated as my goal if everything goes on well. Just a couple of more things here. People have asked that, are there kits that can be used? I have never used them, but they are available in market, and people have been using it. Yes, they are just like, your swimming pool kit, that you will have a strip, you will dip the strip and take out the reading and compare it with the standard chart, and it can tell you whether toxins are present. But these are toxin specific, but these things are available. And in general, for making your lake resilient, and again, it comes back to the nutrient management, how you can reduce whether the nutrient source is runoff coming from the catchment area, or if it's from the wastewater systems, septic systems. You need to deal with that. You also need to look into that. Are there any physical and chemical controls which may help your lake? There may be aeration issue. You may be able to find creating circulation better with some kind of aerators or whatever, right? There are other controls, biological controls, which can also be implemented. People have used them, again, very site specific, very lake specific. And of course, like we talked about, monitoring and early warning systems. So these are where I'm working on at the moment, creating through data collection, whether it's from the drones or from the satellite or from actual monitored data. And of course, the public awareness is the key thing. More aware is public, better are the chances of success for making our lakes resilient. Um, Resources, if you search on Google, there are tons and tons of resources available talking about cyanobacteria and their toxins. I've just taken one example. This is from Health Canada. Google it. It has a very detailed description on cyanobacteria and toxins, and what you or any person interested in mitigating cyanobacteria can do, or if they are already there, then what are the next steps for that. For those of you who are attending from Ontario, Ontario has an amazing program that if you see cyanobacteria in the lake, or if you feel that it's probably cyanobacteria, then you call the Spill Action Center of Ministry of Environment and Climate Change. They will come, they will take the sample, take it to the lab, do the analysis, and give you the report back, and whatever is there. So this is a very good resource, which I will definitely encourage. And if like we do not do it at CBC, but if I get a call, which I get often, then that's where I point my contact people to connect with the ministry folks and get the experts out and send the samples to the lab and go from there. And that's pretty much it. This is my retirement plan. Do some wellness things and yoga and go from there. Please feel free to ask questions, whatever you may have, and we can go from there. Thanks a lot.
Thank you very much, Amanjot, for the excellent presentation. That was great to see. So next we'll move to questions from the chat. And I'll let, I believe Marika will speak to these.
Thank you. So I'm going to read some questions from the chat that we received. The first question is, do shoreline bubblers add enough oxygen into lakes to discourage these blooms?
That's a good question. Again, it depends upon what is the depth of your lake and how the circulation patterns are, right? So there are solutions which are available. I know it's in TRC's jurisdiction. They at Professor's Lake, I believe they're using some kind of, not the piped aerators, but some other mechanism to create circulation. So there are different ways to do that. Yeah, you will need to look into or call some expert to see that where the circulation issues are. And circulation, if it is proper, it definitely helps in improving the conditions for sure.
Thank you.
Great, thanks.
The next question from the chat, thoughts on how zebra mussels clarifying water quality may have exacerbated these blooms?
Yeah, so when we are talking about phosphorus, right? So the most available form of phosphorus is orthophosphate, right? So what zebra mussel is not there. They are not there in general, like the local inland freshwater lake. They're more common in Lake Ontario and maybe some other Great Lakes. So what zebra mussels do is they will they will take the total phosphorus, they will filter them, and then release orthophosphate, which is directly available. So in order for a plant to have phosphorus, it has to be in phosphate form, right? So that is where zebra mussels role comes. Yeah, if they are in abundant, that means available phosphorus will be there, and that phosphorus is easy for any kind of aquatic life to take in particular, whether it's cyanobacteria or any other kind of algae that makes the things worse.
Thank you. I don't believe there's any more questions from the chat, so I'm going to turn things over to Trent and Natasha for final remarks. Thank you.
Thank you, Marika. Yes. So we want to, as we near the end of our presentation, on behalf of all our hosts and attendees, we would like to thank Amanjot for his wonderful presentation. Now that the presentations and question periods have concluded, I want to hear from you. We will be running a series of 5 poll questions. You should see a prompt for. We'll give everyone a couple minutes to select the options that best apply. Once you select your answer, hit the next arrow to move to the next question. And when you reach the last question, please hit submit. If you're watching this webinar on a mobile device, the poll should pop up like a banner. So these questions help us improve our webinars moving forward and help to gather information about what kind of guests we have and how we might be able to curate our webinars better moving forward. So I will let everyone do that. And I'll just let you know, our next webinar coming up will be just about a month from now on October 23rd, also running from lunchtime from 12 to roughly 1:30 p.m. And this topic this time around will be climate change impacts on drinking water safety, with a professor from York University will be our guest there. So look forward to everyone attending that one. Registration links will be up shortly if they're not already. So stay tuned for more information on that. And once again, thank you, everyone. For more information, feel free to reach out to any of our hosts listed on the slide here. So thanks again on behalf of everyone for viewing, and we'll hopefully see you all in October.
Thank you, everyone. We hope you have a great day.